Hi everyone, this is Mazak Bal again. Today's topic is about different consumer board, distribution board we use in domestic properties. Um, I'm going to be going through three of them. The common one, obviously, we do find old one, the rewirable fuses as well. Those is going to be obviously I'm not going to go through those because if you find those refuses. Without RCT protection, they need to be replaced as soon as they can be. Obviously, they don't comply with the regulation, or they're not safe in terms of use. Well, these days where we find things changing day by day. So, yeah, we're going to be concentrating on MCB consumer unit, RCBO's consumer unit, RCD consumer units as well, which is called split load consumer unit. So I will be going through a different consumer unit and explain why we need the MCB. Obviously, MCBs are well explained. What level of protection we can get with the MCB consumer unit and RCD's consumer unit, and what drawbacks are with the MCB consumer unit and RCB, and at the same time RCB consumer units. So there is another one, but I'm probably going to be doing another video which is about arc fault detection device, which is called AFTD. So I will be working on later on, probably sometime. This is a new one. I wouldn't say it's not very common. It's been obviously this is being used now. This is something that's going to be coming soon. It is being used currently, with the multi-stories or old people homes. They are using AFTD, so this is a must-have device there. It protects again arc fault detection, so that's an additional layer of safety. So I will go through those as well. But yeah, I'm going to be starting from MCB consumer unit. But prior to this, I will go through different level of protection, how MCBs uh, give us protect us against our current overload, short circuit, and earth fault. So we're going to go through all this, and I'll explain everything, but we do need to know prior to uh, prior to going through um, different MCB and RCBO functionalities and the level of protection. So this is what we have got in front of me. So in normal circumstances, this cable got live cable that's gonna carry current, and it's gonna go to your appliances, your socket, your switches, whatever you have in your house, and it's gonna go through and to your appliance and come back to neutral, back to your consumer unit. From your consumer unit, it's going to go back to your transformer, and that's the cycle it's going to be completing all the time. So why we got this third cable there? This is where a lot of people, obviously they say call it safety cable, but how does it work? This is what we need to look into it. It is a safety cable. It will protect you. It's called CPC, circuit protective conductor. But we need to know how is that going to protect us, why we need to have this circuit protector conductor within our phase conductor. These two, they're going to be your phase, obviously, the live and line and neutral. So that's what I call. So this is the one end that's going to be going into consumer unit, other is going to be probably going to be going to your switch, socket. It depends what you have on the other end. Sometimes you got fuse spare, sometimes you have a socket, sometimes such as this one. So if I show you this socket, we can see here clearly. Probably not very clear here, but yeah, you might be able to see it's there. It does tell you LME line. So the brown cable is going to go in a line conductor, and N in neutral. The blue one is a neutral. These are standard color for UK and European. So neutral cables, blue one, that's gonna go in N terminal, and you can see those two on the side terminal where we can see this metal. You know, this is the metal body, so which is here. This one. So this is for earth circuit protector conductor. So this is where this middle cable is going to go. So we do need to put a sleeve on top of this cable before we installing, connecting this cable with the socket and any appliances. This was normally you see this bare conductor when you buy twin and earth cable. In this case, this is a 1 mil cable that's not suitable for socket cable. This is for lighting. I'm just giving you example. This cable, obviously, this is going to be a same sort of cable, a 2.5 cable, 4 mil cable, which is going to be used for a socket circuit. But the process is the same. So you need to put a sleeve on top there, and that's going to be circuit protector conductor. This is going to be connected to your when you could use class 1 equipment, 3-pin plug. So these your body, your appliances bodies such as toaster, kettle, microwaves, cooker, whatever you use, that's going to be connected to this circuit protective conductor. And these they're going to be, one's going to bring the current, voltage, current, whatever appliance you're going to be using. So it's 2 kilowatts, so the 2 kilowatts going to be coming through this brown cable and going back to your circuit through this blue cable. So I think that's clear, and obviously I will go through further in in the presentation that I've made on our system. So I'll show you how these going to work and how circuit protector conductor is going to protect us, and what could happen if this isn't working properly, or if the resistance is too high. So how is that going to make a difference if it's low resistance, high resistance, if it's at these external orthophore loop impedance we call, that's again, if the resistance if it's high, if it's you got DNS system and you have your earthing arrangement and it's deteriorated, it's not giving you acceptable value, which is 0.8 in DNS system, and if it's giving you higher value such as 3.99 or 15, worst case scenario 15.5. So what could happen? How is that going to be a problem? What's the solution for those circumstances to avoid those sort of overcurrent situations and these dangerous situations? How we can, what sort of device, what sort of protection level we need to have in place to avoid to keep ourselves safe from electrical overload, short circuit as well. So yeah, we're going to go through. Yeah, thank you very much. Oh, hi. Yeah, this is what I was talking about, this consumer unit. Apologies first. I do not know the reason what's wrong with this system, even though I've got this green and yellow earthing cable there, but it still shows in black color. I don't know the reason, but apologies for the system error. What I can see here, right, I can see it's green and yellow, but I don't know when I check on, after recording, it doesn't show its original color. Is always black, like we had a problem last time as well. Okay, let's talk about this board consumer unit. So I'll be starting from MCB. So this is MCB. This MCB is basically there to protect a short circuit and overcurrent. So if there is any problem on this end, if there's a short circuit, and it will detect if there's overcurrent, obviously there, and the both circumstances this will trigger if it's in a good working order. What we got here in this consumer unit, we got these meter tails. They're coming from from the meter, and from meter they go to the you cut out. From cut out they go to the transformer, whatever the line. If you got a line distribution line on your outside, the outside distribution line to your transformer, local transformer, that's where these connected to. Well, in this video, I've got a TNS system. Previously, I've discussed about PME system. PME system is different because the neutral and earth is combined in PME. But here we got separate neutral and earth all the way to the transformer. So this is what I'll show you in the next few slides. But right now we're going to be discussing what we got here. We got this is 2.5 mil cable, so that's feeding to our socket. We can see this is a I don't know whether it's going to be as I think I've got a problem with this cable. It doesn't show this original color. It's showing black, but it's green and yellow. Yeah, it's going to be connected. It's earth cable. It's CPC. It's also called circuit protective cable. That's going to be connected to this end where we can see these metallic parts bend in there. Basically, this metallic part is going to connect your class 1 equipment, such as if you got to plug the class 1 equipment, such as your toaster, your kettle, your microwaves. It could be any other appliances, any other such as fridge, freezer. Could be sometime they're going to be connected to main earth to this earthing terminal. Okay, this is a line conductor. This is what it brings a current from the MCB, come through this brown conductor and goes back from this blue conductor back to the system, our consumer unit. Here we got consumer unit. This is linked to a man switch. This cable of the meter tails feeding to this man switch, and man switch there's a cable coming out from the bottom end of the man switch and is connected to this. This is neutral terminal. So all these cable, all these circuit, they're going to be connected, and their neutral is going to be connected to here, and their line conductor is going to be according to these MCBs, whatever this be. Could be a cooker circuit, shower, lighting, sockets. They're all going to be connected here, and their CPC circuit protector conductor earth cable that will be connected to this terminal there, earthing terminal. So this earthing terminal is linked to this man earth distributor earthing arrangement. So this cable is man earth that's connected to this earthing terminal. So far we got 3 cables here. It's meter tails, which is one is a line cable. That's going to be your main line cable. So that's, and then the neutral cable, and then we got earth cable there. Okay. As I said, this MCB is going to be is there to protect your appliances, and this cable, bandless cable, to before this get overheated. Obviously, they should trigger. There's a misconception about MCB because I've got 20 amp MCBs. If the load or overcurrent on this side is 20 amp or more, say, more than 20 amp, such as 22, 23 amp, that doesn't mean this MCB is going to trip straight away. It could take time. It depends how much current it's going to take. It depends. It varies manufacturer to manufacturer as well. It could be if it's the 25 amps going through this MCB, it might take about 1 minute, a couple of minutes before it trigger. And if it's a 30 amp, it might take half a minute to trigger. And in Rex type B MCB, it takes about 5 times of its rating. Say if it's 20 amp, it's going to take about 100 amp to trigger instantly. So it will trigger within a time, but within a required time, which could be 0.4 second because it's a TNS system. So in TNS system, we have to achieve 0.4 second tripping time. Okay, let's get to next screen. Yeah, here we've got this microwave connected to this socket, and everything seems okay. We got 2 kilowatt microwave, and if we divide 2 kilowatt with 230 volt to get amps, so it takes about 8.69 amps. And if you want to get the resistance of this microwaves, This going to be obviously we're going to need to divide 230 volt by 8.69 amps, and we will get 26.46 ohms. So this is something I've put it on there just to give you bit more explanation. So just treat them as a water pipe. This is a incoming water supply pipe, and there is the we can say a valve or filter there, and it goes through the filter and come back. So this is what neutral sorry line cable bringing the current to the appliance, and once it's been used, it's going back to the system again. So this is what I put on this one. This is the shield on around these line and neutral. This is main circuit protector conductor in case if there is any leak, anything goes wrong here anywhere. So we got an extra layer which is gonna take the current back to the system. So this is what we got here. And in electric we have got the circuit protector conductor. It's probably showing black in on the screen. As I said, there is something wrong with the system, yeah, but this is what it is. I just put down in the pipe. So there's two pipes there, and the third one is another shield on top. This is what this basically this circuit protector conductor is going to do. If there's any leak in the neutral or line side, that's going to feed back to the system, and it will the system, if it depends how many amps going to go through this circuit protective conductor. This circuit protector conductor, and it will trigger this MCB. Okay. As we know, because we're going to come back to this slide again, and we know that we got 8.69 amps. That's what is drawing this microwave, and its resistance is 26.46 ohms. Okay. Here we got a problem here in this socket. This is the back box of the socket. I think these cables I've just made it, obviously they in contact with the line conductors in contact with circuit protector conductor. So in this case, the current, instead of going through the appliances, that we had a plug in the previous slide like this one, it was going through this plug and coming back to the system again, but that's not happening here. It's just before the plug. It's just before the plug is going. There is a earth fault because this cable is in contact with the earth cable, so the current is coming to from this MCB, and instead of going back through the neutral, is going back through the earth to the system here. And because there isn't resistance such as we had microwave appliance there, and this cable's got very low resistance, so the resistance means this from between this line and earth CPC conductor, we got resistance roughly about 0.25. So that doesn't include the appliance, because appliances it's just happened before the appliances. That's why if it's a low resistance, we know Ohm's law, and it's going to be a more current going through this cable. So in this scenario, we got 230 volt. If we divide by 0.25 ohms, so we get current 920 amps. So if 920 amps going to go through here, this MCB will trigger, as it should trigger instantly if 100 amps going to go through this straight away. But in this case, we got more than 120, which is sufficient to protect this cable. Okay, here. Okay, this is the if somebody's having a difficulty to understand here, I'll give you example again here. This is the water pipe coming here, where we got filter here. Just before the filter is burst here, the water, instead of water going through this filter, is to the neutral at this pipe. Now it's going through this one. So the other pipe, the top layer that we got here, going through back to the system. So this was why we got too much current going through. In a previous slide, we had a just this was the 8.69 amp, and now in this slide it's 920 amps going through, because there's a lesser resistance. That's why there's a more current is being it's going through this circuit protector conductor in real world is going through this circuit protector conductor to the earthing terminal. From earthing terminal, so it's going back to the system transformer, your supply transformer. So everything seems okay in terms of MCB tripping time here, but here sometimes it could be a situation cables fine, they're intact with the socket, they are where it should be, but it could be a problem inside the appliances with this cable line cables in contact with the metal body of this microwaves, and obviously this circuit protector conductors will be in contact with the metal body of the microwaves and neutrals connected where it should be. So this is in contact with the circuit protector conductor, because this came out of the terminal in contact with the metal body. So this is getting continuity from this metal body to this circuit protector conductor. So it's going back to the system again. Now again we got fault. So this cable if we take R1 and R2 reading, obviously including this appliance, this small part, so this is going through this appliance to the circuit protector conductor, that could be slightly higher, and previously we had a 0.25, now it's 0.27 ohms. Now if we divide 230 volt by 0.27 ohms, and it will take 151 amps. So 151 amps once again. This is 20 amp breaker, it will trip straight away, it wouldn't be a problem. So this way here, I mean previous slide we had a problem, you know, here just before the appliance. Now we got a problem with the cables connected to appliance. So this is the filter, the problem inside the filter, which isn't which isn't working where it should be working. So the water is flowing, instead of flowing through this channel, is flowing through this big tube back to the system. So this is what I'm trying to explain. You know, the current, instead of going through the neutral, is going back to the earth cable to the system, and that's why we got our current here. It could be a short circuit sometime between line and neutral, but we're trying to explain, you know, when the current flow through the instead of short circuit, we current flowing through them earthing circuit protective conductor line to circuit protective conductor. This is what we're trying to look into at the moment. Okay, let me bring this meter down as well. Alright, we got a same problem here, and this is the same appliance, but we got very good ZD reading. ZE is basically this. If you take this earth cable out and you take a reading between this line and earthing conductor, that's external, such as we took a reading between circuit protector conductor and line here, that was up from here to there. So this was a reading from here to there, we're taking it. Now this is internal system, so which is called R1, R2. Now external system, we're taking a reading out from this distributor earthing arrangement. We need to take the cable out and take sometime you can put your meter 3 leads, so you can use 3 leads, and one in the line, one in the neutral, and one crocodile you can put on your earthing terminal, sorry, your main earth cable disconnected from the earthing terminal. But it depends. If you got a main switch, you can do you can have 2 leads as well. Your main earthing terminal cable the cable's taken out, and you know, you can put a crocodile there and one lead there to get the ZD reading. But yeah, we got 0.21 ohms. As we said, in the maximum ZD reading for this system should be 0.8. Here we got TNS system, and previously that we made a video about PME system, TNCS system, where this neutral cable and this earth cable, it was in contact, they were combined here, but here they're not combined, they're separate all the way to the transformer. So this cable is not in contact with the neutral, so this is why it's called TNS system. Okay, it's the same thing. We got 20 amp MCB, and the resistance is 0.27. The current is taken out. There's the earth fault current here. We have here 851 amps. So this MCB is going to take maximum 100 amp to trigger within the 0.4 second. This is what we need to achieve. This need to be able to trip within 0.4 second to protect all this system. Cable can, obviously this cable can heat up if this MCB is not going to trip within the required time, and that's all stress is going to be on the cable and appliances. This is why this should trip within the 0.4 second. Okay, and here we got 230 volt. This is external system. As I said, if we divide this 0.2 as we divided 230 by 0.27, this end of this consumer unit, now we dividing this side of the the supplier side of the consumer unit with the ZD value, which is 0.21. So 230 volt divided by 0.21, we get 1095 amps. So this this can easily handle this part. I think arrangement, this can easily handle up to 1095 amps going through this cable and the system here. There wouldn't be a problem because obviously this breaker only need a maximum 100 amp. It's probably going to be less than 100 amp, just give and take. We say 100 amp, it will take to trip instantly within 0.4 seconds. So we gotta, and if it's gonna need it, this should be okay. Obviously the system can handle up to 1095. There shouldn't be any problem. Here we got an issue now. Previously we got this ZD value 0.21. now we got 3.99. so this is probably deteriorated here, and this is not very good connection here. There could be any reason, rust around there, so we're getting higher ZD value. In those circumstances, if we divide 230 volt by 399, we got 57 amps. So we got a problem here because this current, where previously we had 1095 amps, we could take this system here. Now we can to achieve 0.4 second disconnection time. Now it can take up to 57 amps. So to trigger this MCB, obviously it needs 100 amps. So this is more than what this can take. So here I'll give you an example. We got this current coming from line conductor to this microwave here. We can say this is a filter here, the water supply, and this filter obviously is not working. It's going and it's open, and it's going to the system instead of going through this channel. Is going through this circuit protector conductor in the real in real world. So this going back to the system. When it comes to this here, this water, and obviously there is a problem here. Obviously it's got higher resistance there, and if the resistance is higher, we can't achieve disconnection time 0.4 second. That could be an issue. That means all the stress is going to be on this appliance cable, this cable, and MCB. It's probably going to trip, but it will take time. It's going to take a bit long time to trip. And let's go to here. Okay, this is the worst case scenario. If this is the way we got a ZD value here, because we got loose connection here, rusty system, it's not giving ZD value very good. It should be 0.8, but it's quite high. there could be any reason here, the problem here, or could be back there. So, I mean, it's not, and that's why we can't achieve 0.8 in this situation. We got 15.5 ohms, which is quite high, and obviously now if we divide 230 volt with the 15.5 ohm, we got 14.8 amps. So this can take 14.8 amps to maximum amp. So we gotta this breaker to trip instantly needs 100 amps. So we got a current here, 853 amp flowing in this cable and here and there, but the breaker is not tripping because this current needs to go through this channel, from this, because it's in from earth cable back to this earthing terminal, from this way back to the transformer, and then back to this line conductor again, back to this MCB. Was taking long. Okay, because this circuit to at the tripping within the 0.4 second, you need around 100 amp, but we only got 14 amp, which isn't even equal to 20 amp, which is this MCB rating. So this is where we're going to have an issue. There's all stress. These 853 amps going to be flowing here in the cable, and that could lead to this cable catching fire, or this appliance catching fire, because this MCB is not tripping, and it's obviously it's not tripping because of the it's not obviously we haven't got it's not detecting this current because of this earthing arrangement. It doesn't have very good earthing arrangement here, and it's got quite a high reading. So this is we can have an issue, and so you can get, obviously if it's a problem here, you can get a shock as well. It's taking long to trigger. Here, this is slightly different to what we've seen previously. Okay, we haven't got a problem here, everything's fine this side, but we got a problem here where this cable is in contact with the microwaves, and there's a leakage here. This cable is in contact with it, everything is fine, but there is a slight leakage here. The current is flowing, coming to this line conductor and going back to through the neutral cable back to the system, but some of the current is leaking, and this leakage is obviously is going back to the system through this circuit protective conductor. So we got a current coming to this microwave from the line conductor, but it's got two paths back to the system. So one is here. In this case, we probably haven't got a overload over current, because if you're getting 8.69 amps coming to this microwave via this line conductor, and it's going back 7.69, so we've got 1 amp flowing here, which is enough to it's a fatal, which is enough to kill anyone, they come in contact with the live part of the appliance. But the good news is, I think arrangement is good. If it's going back to the your circuit protector, you're probably going to feel it, but it might not be as bad as if you don't have earthing arrangement. If there's no earthing arrangement there, then it could be a problem. But what I'm saying, sometimes this current is flowing there, but you wouldn't know, because it's taking earth route back to the system, so you wouldn't know. You probably were doing whatever you're doing in your home. Sometimes you're probably going to get tingle, but it could be an issue if this cable is disconnected somewhere, it's broken, or inside the socket, if it's loose here, then in those circumstances this current has got no path, and it will go through your body to the ground, and this is where you can get shock. Okay, this is the final slide. Okay, here we remove this circuit protective conductor here, the third layer I said. Now, obviously as I said previously, if it's not connected, if it's loose, if it's disconnected anywhere, in those circumstances, the current is going through the leakage current is going through your body back to the system here, transformer. So this is where you can find, obviously it could be a dangerous, very dangerous. Okay, to avoid this, we haven't got a protection in this consumer unit here because they detect our load and our current. It doesn't detect this minor earth fault, which is, in these circumstances, is everything's fine, in terms of short circuit and our current, but we got a slight leakage which is fatal, and if you don't have the circuit protector conductor, then it's going to go through your body, and this is where it could be very dangerous. So this MCB is not going to protect you. Okay, we'll talk about on next. I think this video is, I wasn't expecting this. It's a very long video, so we're probably going to be discussing about RCD protection, how we can avoid this sort of situation if we come across with this sort of problem. So how RCD is going to protect us. So probably I'll make another video about RCD protection. Thank you.